morning, mathematicians. In today's work, we are going to revisit the triangle congruency postulates and theorems and expand our understanding of those just a little bit more. And then we're going to walk through several proofs involving the use of triangle congruency statements. In yesterday's discussion, I talked about the four primary triangle congruency statements, side, 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 angle, angle, and angle, angle, side. And I touched on the hypotenuse leg theorem regarding right triangles. So I wanted to emphasize that this morning before we started, and to just show you how that works. With a pair of right triangles, you already have one pair of congruent angles, and that would be the right angle in the two triangles. So you really only need two more parts, or two more pairs of congruent parts to be able to prove congruency between the triangles. And the hypotenuse leg theorem is the most common, and that's just simply saying that if you know you have a pair of congruent hypotenuse and a pair of congruent legs between two right triangles, you know that you have congruent triangles. Now, there are other combinations that you will see used in proof with right triangles, but those combinations really go back to what we've already looked at. For example, if you can prove that another pair of angles and one pair of the legs in a pair of right triangles is congruent, that's the angle-leg theorem, but that's really going back to the angle-angle side or the angle-side-angle, depending on the order of those congruent parts within the triangles. You can use a leg-leg theorem, but you can also state that as side angle side, because if you know that the two pair of legs between two right triangles are congruent, you already know that the angles between are congruent, because the right angle always occurs between the legs of the right triangle. So then that would really be the side angle side congruency. And then if you have the two hypotenuse of a pair of right triangles congruent and one other pair of angles, that's really going back to the angle-angle side congruency. So update your notes with what you see here, and then we'll proceed to do some practice with proof. All right, in the first proof today, we are given that segment MP bisects angle LMN. So we know that we have a pair of congruent angles right here. Let's go ahead and mark up the picture as we go through the proof. We're told that LM is congruent to segment MN. And we're being asked to prove that segment LP, which is right over here on the right side, highlighter again, is congruent to PN, or NP. Okay, so we'll start with our proof with the given statements. And we know that, we already said as we drew the picture, that if PM bisects angle LMN, we have a pair of congruent angles. And I'm going to go ahead and mark that as angle 1 and angle 2. And you can do that in your proof if it helps. Okay, so 1 is right here, 2 is right here. And we know that those two are congruent by definition of angle bisectors. So let's look at what we have so far. So far between the triangles PNM and PLM, we have a pair of congruent sides. We have a pair of congruent angles. We need one more pair of congruent parts to have to be able to use one of our congruency statements. And right in the center we have segment PM occurring in both triangles. So we can say that segment PM is congruent to PM by the reflexive property. So now we have a pair of sides that are congruent, a pair of angles that are congruent, and another pair of sides. So we can say that triangle NPM is congruent to LPM by side angle side. That angle is occurring between the two pair of congruent sides, so it's side angle side. And then that way we know, at that point we know that NP has to be congruent to LP because of corresponding parts of congruent triangles that are always congruent. So these aren't so bad. As you go through your proof, you're looking for the possibility of using congruent triangles to prove what you need. All right, in our next proof, go ahead and draw this picture out, and let's mark up what we know. We know that segment BE bisects segment AD, and that angle A is congruent to angle D. So we are trying to prove that segment AB is congruent to DC. So let's highlight what our goal here so we can see, so we can visually see the end needs. So we're looking to prove that these two segments are congruent. Okay. We are told that angle A is congruent to angle D. So we already have a pair of congruent angles, and we have some bisecting segments going on. So we know we have some congruent segments that we can talk about as well. So let's start off with what we can find. I've marked angles 1 and 2 in the center of the picture because we know that there's an angle pair relationship there. We know that they're vertical angles, and we know that vertical angles are congruent. So I have now, where I had A and D congruent to each other before, I now have another pair of congruent angles. Okay, so I have two pair of congruent angles. I need some sides to be congruent in order to proceed with my proof. Well, I know that I have bisectors going on, so I can do something like, I'm going to start with segment AE. I know that AE has to be congruent to ED because we were told that BE bisects segment AD. So we can use that definition of segment bisectors to prove that. So now I have a pair of angles, a pair of sides, and then a pair of angles that are congruent. So by angle, side, angle, I know that triangle AEB is congruent to DEC. And because AB and CD are occurring within those triangles, I know that they are congruent by corresponding parts. All right, in the next proof, we have a quadrilateral here, and we are told that HJ is parallel to LK. So parallel lines right here. And I have JK parallel to HL. So I know I have a parallelogram. And then we're being asked to prove that angle H is congruent to angle K. So again, we have a pair of triangles that we can work with. Let's see if we can prove that triangle LHJ is congruent to JKL, and then we can use corresponding parts for that. All right, so let's start with what we know about parallel lines. If we have parallel lines, we have some angle pair relationships to work with. So I'm going to go ahead and mark some angles here that I know I'm going to use. Let's start with this one. Start with angle 1. Call this 1. Let's call this one 2. Let's go ahead and call this one 3. And let's call this one 4. It's not a very pretty 4, is it? Okay. I know that angle 1 and angle 4 are going to be congruent because they are alternate interior angles to a pair of parallel lines. I also know that angles 3 and 2 are going to be congruent by the same relationship. So I'm going to just make one statement here about the two pair of congruent angles. And then let's reassess what we have so far. We have two pair of congruent angles within those two triangles that we're trying to prove congruent. So we need a pair of sides to be congruent. Well, segment JL is occurring in both triangles, so we can use that reflexive property and state that LJ is congruent to JL by the reflexive property. So now we have angle side angle working for us, and we can prove that triangle HJL is congruent to KLJ. And we know then that angle H has to be congruent to angle K by corresponding parts. So again, hopefully you're starting to see a pattern develop in these proofs. All right, next proof. We have segment MS is parallel to RT. So let's go ahead and mark that. And we know that MS is congruent to TR, so we'll mark that as well. And we're being asked to prove that A is the midpoint of MT. Now this is going to have a similar flow to it as the proof that we did a couple slides ago. So let's go ahead and start with our given statement. We know that MS, go ahead and write all that in. MS is parallel to TR, segment MS is congruent to TR. And I know I have a pair of congruent angles in here because they're vertical angles. So I have a pair of congruent angles, I have a congruent side, so I need another pair of congruent angles to make this work. Well, I have parallel lines, so I know that I have some alternate interior angles to work with. And I know that angle M is going to be congruent to angle T. You could use angle R and angle S if you want, because you're still working on the same pair of parallel lines. And that would be alternate interior angles. So now I have the angle side congruency working for me. So I know that triangle MSA is congruent to triangle TRA. And then I know at that point that segment MA has to be congruent to segment TA by corresponding parts. And that, because those segments are congruent, I can use the definition of a midpoint to say that A is the midpoint of segment MT. All right, a couple more proofs, and then we will wind this up. Actually, I think I'll pass the last one because we've covered so much in these proofs. All right, in this proof, we are given that segment AD is congruent to segment AE, and that angle ACD, this is a little more complicated because we have some overlapping triangles, is congruent to ABE. And we are being asked to prove that triangle ABC, the overall triangle, is an isosceles triangle. So let's look at what we see here. We can't really get to the big triangle right now, but we do have a pair of overlapping triangles. If you look carefully, we have triangle A, E. Sorry, I'm working off of a slate and it's kind of hard to write on that. B. So think about triangle AEB in there. And then think about triangle ADC. So can you picture those two overlapping in this diagram? Well, we are told that AD is congruent to AE. Okay, we were told that BC or B and C, ACD and ABE, are congruent to one another. If you'll look at this carefully, you'll see that segment AB is occurring on one of those triangles and AC is occurring on the other. Well, those are legs of the isosceles triangle, and if we can get those two to be congruent, we know that ABC is isosceles. So let's take a look at this. We have a pair of congruent sides between our two smaller triangles. We have one pair of congruent angles. So we need another pair of congruent angles to work for us. Well, angle A is occurring in both of those smaller triangles. Well, we know that A is going to be congruent to A by the reflexive property. So we have this smaller pair of triangles congruent to each other now by angle, angle, side. Well, now we have corresponding parts working in our favor. We know that AB has to be congruent to AC, which is what we were looking for. Now that we know that those two longer legs of that big triangle are congruent to one another, we can say that ABC is isosceles by definition of isosceles triangles. All right, I'm going to stop here, and we'll continue to work with proofs through the next few days, but these give you an idea of how to apply the triangle congruency statements in your work. So take your time, walk through these, make sure you have thorough notes and thorough copies of the proofs, and we will continue together. Thank you.